The Arctic. Ice. With temperatures that can reach minus 60 degrees Fahrenheit, the Arctic draws scientists to study the extreme limits of life on Earth. Scientists come to this National Science Foundation facility in Barrow, Alaska, to observe the processes that control the nature and distribution of sea ice. In an environment that supports a 1 to 4 meter thick cover of sea ice, you might not expect that animals actually live within the ice, but they do. Sea ice is different from the ice cubes in your freezer. This is largely due to the presence of salt. In the cold air, when ice forms from the salty ocean, the salt is not incorporated into the ice crystals. Instead, pores or pockets of highly concentrated salty water get engulfed into the matrix. Under the influence of gravity, brine or fluid pockets in sea ice tend to drain downwards toward the underlying ocean, creating brine channels that grow in width over time. Microbial life. Animals live in those salty brine pockets or channels. These pockets both alter the structure of the ice and provide the habitat for the living organisms. In April 2005, oceanographer Christopher Krems of the Polar Science Center at the Applied Physics Laboratory, University of Washington, traveled to the ice edge near Barrow, Alaska.
You can see how channels are colonized by microorganisms that produce slime, which then can weaken the structure of sea ice.
Here, native peoples, Inuits, use slime to protect them from frostbite. Ice is the way of life to native species and peoples. Inuits travel over the ice to hunt seals and birds to feed their families. Scientists study sea ice for all sorts of reasons. Here are just a couple. Sea ice is a barometer of change in polar regions that could impact our global climate system. Mike Steele, senior oceanographer from the Polar Science Center, comments,
"We have learned that warming is occurring across the planet, but is most severe in the Arctic."
Understanding the Arctic's influence on and its response to global heat distribution in the oceans and atmosphere could tell us about the possible danger of climatic chaos. We might learn when to expect such events or perhaps how to avoid them. Another reason scientists study sea ice is to discover low-temperature survival strategies. Attachment to a surface often facilitates bacterial survival in the marine environment, and when the ice forms in the autumn, sea ice frequently incorporates significant amounts of sediment grains or dirt, which mainly come from coastal erosion. In the Arctic, microorganisms and their slime attach to those sediment grains and to the walls of the brine pockets, thus becoming inseparable from their habitat. We can't understand one without the other. Did you know that xanthan gum, an ingredient in ice cream, is really bacterial slime? Now let's take a closer look to discover something of the physics of sea ice. You can slice ice and see the growth history just like you can with the rings of a tree. Frost flowers form on the surface of new sea ice as surface brine pockets are sucked upwards into the dry, cold atmosphere. The water evaporates and the salt crystals are left behind. Melt ponds filled with fresh water are unique to the Arctic. They mark where sea ice is melting on top during summer. If the melt pond gets deep, it can melt right through the ice flow into the ocean below. Scientists speculate about what the future holds for the Arctic. Mike Steele comments,
"Scientists know that over the last 20 to 40 years, both the extent and thickness of the sea ice cover has been substantially reduced. That's why NASA and NSF are interested in this research. Here you can see the variability of the shrinking sea ice cover."
Balance between the climate and the life cycle of organisms is critical. Fresh water flushes through the ice, taking nutrients and microbes with it and giving rise to life in the ocean below. In other words, ice is a force that begs our attention.